Okay, so the last two that we're going to do is number 53 and number 54. They are very similar to number 41, which was covered in a previous video. I believe it was entitled Finding Delta for Any Epsilon. So I'm going to be a little bit more, or I'm going to be a little less verbose in covering this problem. So, the problem in number 53 says to find the limit as x goes to 1 of x squared plus 1. We do direct substitution. We get 1 squared plus 1 equal to 2. So we have to prove that this limit is equal to this value of L, 2. So that means that we need to find a delta such that if x is no more than delta away from 1, then it will imply that our height of our function is never more than epsilon away from 2. So we look at this height, and we say, all right, well, x squared plus 1 minus 2 is the same thing as x squared minus 1. We can factor x squared minus 1 into x plus 1 and multiply by the quantity of x minus 1. But x minus 1 is the width of our box, whatever delta that we choose. So we have control over that. So we can say that this will be less than the quantity of x plus 1 absolute value times delta. We don't have control over this, but we can bound it on some arbitrary interval. So we'll assume that that interval is delta. That will assume that delta will be less than 1. So 1 on either side of our limit point or less. So that means that x would have to be somewhere between 0 and 2. So this factor of x plus 1 is always going to be less than 3. And it can't be any more than 3. So we can say that this quantity here has to be less than or equal to 3 delta. And then that, if we want that to be less than epsilon, we can just take delta equal to epsilon over 3. And that would only work out if our assumption that we're somewhere within delta less than 1, or that the width of our box is still less than 1. So it would only work for epsilon less than or equal to 3. But if epsilon was greater than 3, let's say 7 or so, something like that, we could just clamp delta to be equal to 1. Because this smaller, thinner box still works. And that's what we had basically said in number 41. And the more compact way of saying that is take the minimum value of 1 and epsilon over 3. Okay, let's look at number 54. Hold on one moment. Sorry about that, technical difficulty. In number 54, we try to find the limit as x goes to negative 3 of x squared plus 3x. Again, we do direct substitution. So negative 3 squared is 9. 3 times negative 3 is negative 9. So 9 minus 9 is 0. So we claim that 0 is our L value. That's what this function is equal to. So we need to show that if x is no more than delta away from negative 3, then it will imply that the value of our function is no more than epsilon away from 0. Right? So this is the same thing as saying x squared plus 3x minus 0 absolute value less than epsilon. So in order to prove this, we can factor out a x from both terms inside the absolute value, and then break that absolute value apart into two absolute value quantities multiplied together. So we get the absolute value of x times the absolute value of x plus 3. This quantity of x plus 3 is the width of our box, right? so that's equal to, or less than, it's going to be less than the delta value that we choose. We don't have control over this factor of x, but we can set ourselves to an arbitrary interval. We'll again say less than 1. So that means that x has to be something between -4 and -5. The absolute value of x is max, is the maximum for the absolute value of x on an interval of -5, or excuse me, -4 to -5 is when, well, it's not when x equals -5 because technically it can't be equal to -5, but it's at least bounded by that, right? It can't be any more than 5. So we can replace the absolute value of x with 5 if delta is less than 1. And then therefore, if delta is less than 1, we could say take epsilon and divide it by 5. So again, we do the clamping as before, so we can say that delta is the minimum of 1 and epsilon over 5. So if you gave me an epsilon value of 4, I would give you a delta value of 4/5. If you gave me an epsilon value of 0.001, I would give you a delta value of 0.001 divided by 5. If you gave me an epsilon value of 10, I would just say, hey, let's use 1. And it would work out well. So that's all of the delta epsilon proofs that we're going to do. There might be 1 or 2 questions on a quiz that you would have to answer. Okay. And that's it.